The electrical potential energy storage in a capacitor is today's video lesson. The energy storage in a capacitor, or the potential or the electrical potential energy storage into the capacitor. Okay, welcome to Zalot Studio channel. Zalot Studio channel is focused on simulation and a virtual physics lab. So what mean the energy stored into a capacitor? If a capacitor holds a charge, capacitor that is stored or holds a charge Q, the potential difference is V. Then the energy is contained, the energy is stored into the capacitor is given by the energy stored on the capacitor, the energy stored or the capacity, the capacitor to be storing energy is equals the total stored charge or the total holding of the capacitor stored charge that multiplied with the average voltage through which it is held to be lifted, which means the average voltage. So the average voltage is equals the initial voltage plus the final voltage divided by 2, or 1 over 2 times V initial plus V final, where V initial is 0, when V initial is 0 and V final is the given one, which give 0 plus V is 1 over 2 V. 0 plus V is V, V times 1 over 2, that's 1 over 2 V. So the energy stored into the capacitor is equals the stored or the capacitor holding charge Q multiplied by the average voltage, the average potential difference, or Q times 1 over 2 V. 1 over 2 V is the average voltage, which is equals 1 over 2 times Q times V. This is the total energy stored, or the electrical potential energy stored in the capacitor, which is 1 over 2 times Q times V. Q times V. Alternatively, the same expression including capacitance. So the capacitance is equals to Q over V. Q over V. So inserting this value into Q. So Q is equals to C times V. C times V times V. C times V times V times 1 over 2. 1 over 2 times Q times V. So Q we mean C times V. Capacitance times potential difference. V times V is V square here. Okay, coming to the simulation here. This one is the capacitance, which is C, and this one the potential difference, that is in our case 1.5 volt, 1.5 volt, and at a separation distance 10 millimeter, and the plate area is 100 millimeter square. To be increasing the separation distance, the capacitance of a capacitor is increases here. Okay, so this one is the capacitance at 400 millimeter square. The plate area is 400 millimeter square, and the separation distance is 10. It to be 0.35 times 10 to the power of minus 12 Faraday. So here the energy storage energy is what? 1 over 2 times C times V square. Okay, to calculate these values, 1 over 2 times what? This value times the square value of this. Okay, 1 over 2 mean 0.5 times C 0.35 times 10 to the power of minus 12 times how much? 1.5 times 1.5 square mean, which gives what? This is the energy multiplying with 10 to the power of minus 12, which is nearly 0.4 times 10 to the power of minus 12 joule. This is the energy. And energy is equals to half of Q times V. So how to be Q mean the charge that is stored into a positive plate is 0.35. Charge here half times, to be taking the calculator, half of 0.5 times Q times Q means 0.53 again times V is 1.5 here equals 0.4 times 10 to the power of minus 12 coulomb times voltage is joule. So this is the stored energy on a capacitor. That is the electrical potential energies that is stored in capacitor, which is 1 over 2 times the stored charge, that Q, times the potential difference V, or 1 over 2 times C times V square. Okay, thank you. I will come back in the stored energy in a dielectric material, the capacitor in a dielectric material. Goodbye today's.